Okay, so let's move on for the challenge problem of the chapter 20. Okay, so the first one. So we have a segment definition of we have a function defined by the segment. Okay, now let's first, let's see A, B, C, right? So I want to take some extra time. I want to draw the function of the fx, okay, in different sections, okay? So the first is the x is less than -6, right? So we divide the plane into the -6, 0, this one, right? And to the 5. So we divide the plane into 1, 2, 3, three segments, right? So if between the -6 and the 5 is 2x squared, okay? So that's okay. So we know this point, okay, to the 5 is the 50. So it's the 5 and the 50. And we know this one is 6 is -6 and the 72, right? Okay, so this is the one section. And now let's see this section. Okay, x greater than 5, right? So it is the 2 minus the root 5, right? So here is the point, is the solid inclusive, right? Here is exclusive. So 2 minus root of 5 is somewhere point is 2 negative 0.2 something, okay? So here is negative 0.2 something. So at this point, okay? So it will be like this, okay? So that's the second segment, and the last segment is this, okay? So if x is less than -6, so this is less than 0, right? So it will be -2x minus 3, right? Okay, so if y equals -2x minus 3, that means the take the point of the -6, right? -6 is the 12 is 9, so -6 and 9. Passing this one, and the slope is -2, okay? So this is the how this function looks like, okay? So three sections. Now let's work on this, okay? The first is f3, right? So we can see f3 is located here. So f3 is 2 times the 3 square is equal to 18, okay? I draw this one is to let you see how it looks like, okay? Then the this f2 of the 3 means f of f the 3, okay? It's f of the 18. So next time is 18, right? Is 2 minus the root 18 is 2 minus the 3 over root 2. Now f3 of the 3 is f of this, right? Is f of the 2 minus 3 root 2, okay? So let's see the range of this one, okay? So it's somewhere is 2 minus 3.3 times the negative 1.4 or 1.5, right? So you can see this number is the times 1.4. So this number is like 4.5. Negative 4.5 is somewhere around negative 2.5, right? So negative 2.5 is still within this range. So it's equal to 2 times the 2 minus 3 root 2 of the square. So what we can get is the 44 minus 24 of the root 2. Okay. So that's the for question A. So for question B, okay, we want to see for what values does fx equal x, okay? So fx equal x means y equal x, right? So now we need to see, let's draw a y equals x. So y equal x, right? So we can see the intersection here, right, is only with the section of the 2x squared, right? So now let's see, we can, now we, if you decide this, now the next is just simple calculation, solve the equation, okay? Now let's solve the equation of the, so we know it's the 2x squared is this section, right? The minus x, right, equals 0. So we have the 2x minus 1 times x equals 0. So we know x1 equals 0 and the x2 equals the 1 over 2. So all these 2 points should be within the range of the -6 to +5, right? So they both less than equal than 5 and greater equal than -6. So that's the answer. What's the C? C is find the value such as that fx equals 9. Okay, so fx equals 9, right? So you can see fx equals 9, right? You can see because this one is 9 is exclusive, right? Not this segment. So the only thing with the segment is here and the here, right? Still with the 2x squared, right? So that means the C is the 2x squared equals 9. Then you can see the x squared equals the 9 over 2. Then x is equal to, so this one is also less than 5 and greater equal than -6. Okay, so the answer is this. Next. Okay, so before we eliminating, okay, before we first, okay, don't do elimination before you do casework, okay? Before you write down the restrictions. I will talk about it here using this case, okay? It's t minus 7, right? So here we can write as t minus 3 and t plus 1, right? And equal to the t plus 2, right? Here we can see is the t plus the 5 and the t minus 3, okay? So we can see we have a t minus 3 here, t minus 3 here, right? But before we do elimination, we need to write down t cannot be equal to 3, okay? Sometimes when you solve equation, you have the t equals to 3, okay? Now you can cancel it, then do the cross product. So we have the t minus 7 and the t plus 5 is equal to the t plus 1 times the t plus 2. Okay, so we have the t squared minus 2t minus 35 is equal to the t squared plus 3t plus 2. Okay, now we can cancel this. Then we have the 5t is equal to -37. So we can do the t equal -37 over 5. So this one doesn't equal 3. So that's the answer. This one, okay? So you can see it's a quadratic equation with a disguise. So we have to see x plus 1 equals y. Then we have to see y greater or equal than 0, and also x need to be great. Y cannot be equal 0, right? Y need to be greater than 0, and x need to be greater than this. Now let's solve the equation. So y plus the 1 over y is 13 over 6. So now we have the y squared plus 1 is 13 over 6y. Then it's the y 6y squared minus 13y, then plus 6 is equal to 0. Okay, now we can try to solve this quadratic equation. Okay, so we can do the 2 3 and 3 of 3 2, right? So now we do the 2y minus 3 and 3y minus 2 equals 0. So y1 equals 2 over 2, 3 over 2, and the y2 equals 2 over 3. Okay, now for each of them, right, let's see. Okay, so that means the x plus 1 equals to the 9 over 4, and the x plus 1 equal to the 4 over 9. So for here, x1 equals the 5 over 4, and this one is x2 equals the negative 5 over 9. Next. So this is the to solve the the quadratic term, right? Okay. So now let's do it. So we can square on both sides. Okay. So but when we before we do the squaring, okay, let's do c. The c x need to greater than the negative 1 over 4, and x need to be greater or equal than 11, and the x need to be greater or equal than the 2. Okay, so now from this 3, now we know the x need to be greater or equal than 11. Okay, then the next step is the 4x plus 1 is equal to x minus 11 plus the 2x minus 4, right? Now let's do the square. So it's 4x plus 1 is equal to x minus 11, then plus 2x minus 4, then plus 2 root of x minus 11 root 2x minus 4. Okay, then what we have here is equivalently is x, right? Here is the negative 15, okay? Then is plus 16 is equal to the 2 of the, now we have the 2x square, right? And minus the 44, minus 22x, minus 4x is minus the 22 for 26x, right? The plus 44. Okay, now we can further square it. We can further square it. We have the x plus 16 of the square is equal to 4 of the 2 of the 2x square minus 26x plus the 44. Okay, then we can have the x squared plus the 32x plus the 256 is equal to 8x squared, then minus x, then plus 176. Okay, now we can have the 7x squared, right, minus the 136x, right, and then we have the minus the 80, yes, minus 80 equal to 0. Okay, so now let's see. Okay, so we have the 1 and the 7, and we have the 24. Okay, so now we have this one, right? So this one is negative 120, and yes, so now we have the x minus 20 and the 7x plus 4 is equal to 0. Then we have x1 equals 20 and the x2 equals the negative of the 4 over 7. Okay, but here, don't forget, we need x greater or equal than 11, right? And also we need x greater or equal than 11, so the final answer is x equals 20. Next. So for the recall the expression of this one for fractional graph inequality of this. Okay, so now let's see, the x is the fractional part, means for example is 1.2 is equal to 0.2, okay, and 1.5 is 0.5, and integer something point y, okay, the answer is, if it's a positive, okay, it's positive number or greater or equal than 0, okay, then this one will be the 0 point y, okay. If it is negative something something y, okay, if it is negative, okay, this one is equal to the 1 minus y, 1 minus 0 point y, okay. So now let's see, okay, how let's draw it, okay. So you can see this is repeating, right, because it doesn't relate with the integer, so it's repeating here. So let's see from the 0 to 1, okay, from the 0 to 1, right. So the 4 times of the x, right. Okay, when it goes to 1, it becomes 0 again, right. So here it goes from here to the 4. Did you see it? So this one is the 4. It's 0 and the 4, right? It's a linear. It's 0, it's 0, then goes approaching to the 4, but never can equal to the 4, right? So then when it goes to the 2, it's also do like this, right? It's 4 of that. Then goes to here, then we go to 3, it's also like this. Okay, then it's negative 1, it's the same thing, right? Here's the circle. This is the negative 1. Negative 1 is 0, and it's also approaching to this. Negative 2 is also approaching to this. Okay, now we want this one is between 1 and 3, right? So here is the 3, here is the 1. Okay, so let's use the dash line to see it cannot equal. Let's use the solid line, means it can equal, right? So this is the 1, okay? So now you can see the point is from here to here, 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 okay? Now let's see the offset, because this is the 1, right? So this is the 1/4, right? This is the 3, right? So this is the 3/4, right? So for every integer point, the fractional is between the 1/4 to the 3/4, 1/4 to the 3/4. It has been repeating, okay? So this is how the to graph this inequality on the number line, okay? Next. So what are the real value of the x that can minimize this, right? The absolute value of this, okay? So y is equal to the absolute value of this. Okay, so let's graph it. I mean, if you understand this, you can see the y equals the 6, right? And the x squared minus the 1/3 of the x, right? So in order to make 1/3 of the x, then we need the 1/6 of the square, right? Then we can take out of the 1/6. So in this case, our center is about the 1/6, right? Okay, and then it's negative 1/6, right? Then it will be looking like this, right? Then the absolute value is what? You just flip this one up. It's the roots, right? You flip this one up. Okay, so now you can see the minimum value is, this is the, so the minimum value is 2 roots. Did you see it? So now solve the roots, okay? 6x and x minus 1/3 equal to 0. So the minimum value x1 equals 0 and x2 equals 1/3. Next. Okay, now it's the ceiling function. Okay, the ceiling function means, okay, for example, it's the 1.5 equals 2, then the 0.1 equals 1, and the negative the 0.9 equals 0, and negative 1.5 equals negative 1. Okay, it's rounded up to the next to the closest integers. Okay, this is called the ceiling functions. So now you can see if it is the perfect square, right? So for example, if the square root of n square is equal to n, right, then when you take the ceiling function, it will be equal to n, right? And but if you have the square root of the ceiling function of the x square, then equal to the some integers point y, right? So this one will be, for example, it's t and y, then it will be t plus 1. It's always round up. Okay, now we need to find, so the divide area is the perfect square. Okay, so the first perfect square is 1, right? Is 1 square, right? The second perfect square is 2 square, right? And the 3 square, right? And the 50 is 7 square, right? So the 49 is 7 square, right? So let's list it: 4 square, 5 square, 6 square, then 7 square, then 50, right? 50 is 7 square plus 1. Okay, 50 is the last one. Okay, now let's count it. 1 square, we only have 1, right? And the 2 square, how many 2 squares? From 2 to 4, right? They all are round up because it's 1 point something to 2, right? It's all getting 2. So 2 has a number of 2 square minus 1 square. This is the number of 2's. Okay, it's 1 and the number is 1. Okay, so here is the number. Here is the value. Okay, let me erase it. Now let's write it clearly. Okay, so now here is I have 1, and here I have I have the 2 square minus 1 square, right? Here okay, so here the value is 3. I have 3 square minus 2 square. Here the value is 4. I have 4 square minus 3 square. Here I have value is 5. I have 5 square minus 4 square. Then here is the value is 6. I have 6 square minus 5 square. Here the value is 7. I have the 7 square minus 6 square. Here the value is 8. I only have 1. Okay, now let's see the total. Okay, the subtotal for each category. Okay, the sum here is 1 times 1, right? Here is 3. 2 times 6 is 2 times 3, right? Is 6. Here is 3 times the 5. Okay, 3 times 5 is 15, and 4 times 7 is 28. Then 5 times 9 is 45, and 6 times 11 is 66, and 7 times 13 is 91. 8 times 1 is 8. Okay, then you need to sum all of them, right? Once you sum all of them, and you can get the final results. It is 260. Next. So you can see we take the root 3, right? Once you take the root 3, it doesn't matter if the internal is a positive or negative, right? If even roots, you have to make sure the number inside is greater or equal than 0. Okay. So in this case, we can square both sides, cube both sides, right? X cubed minus x squared minus 10 is equal to this one's minus 1 is cube is x cubed minus the 3x squared plus the 3x minus 1. Then we can organize it. So we can cancel this. So it's 2x squared, right? And minus 3x. Then this one is minus 9 equals 0. Okay, so we can do 1, 2, and negative 3 and 3. So here is the negative 6 plus 3 is negative 3. So now we can see it's x minus 3 and 2x plus 3 equals 0. So we have x1 equals 3 and x2 equals the negative of the 3 over 2. Okay, next. So we're trying to find the constant a, b, c such that of this. Okay, so there is a simple way to do it. Okay, there is one way to do it. The first method is you can do the same thing. You can do this. Okay, so you can see the a of the x plus 1 of the square, right, plus the b of the x and x plus 1, right, plus c of the x, c of the x, yes, c of the x, right, is equal to the 3x minus 2. Then you can organize. Okay, then you can see you have a x squared term is 0, then x term is should be equal to 3, and the constant should be equals to negative 2, right? Then you can solve equation. This is the first method. Okay, I want to talk about a second method. It's a little bit faster. Okay, let's see. Let's see. This is the fx, right? Equals 3x minus 2 and x cubed plus the 2x squared plus x, and we can see it's a over x plus the b over x plus 1 plus c over x plus 1 of the square. Okay, so in this case you can see the bottom can be do x and x plus 1 square, right? Okay, let's see it. So how to calculate the a, right? Did you see, I mean, if we times the x times fx, on this side will be a plus the bx over x plus 1 plus the cx over x plus 1 square. Now if we see we let the x equals 0, what happened? This is gone, this is gone, right? So now the a is equal to x times fx, and x equals to 0. That means let's do this. Okay, this is the fx, right? So it's the x times the fx, right? So here is the x plus 1 of the square, then 3x minus 2, then x equals 0. What do we have? So x equals 0 is 1, then it's negative 2. So now we have a equal negative 2. Okay, now let's solve the c. C is simple, right? B is because I mean when you times the only times the x plus 1, right, and the x plus 1 is here in the denominator, so you cannot see x plus 1 is 0 because it become infinity, but c is easy. So x plus 1 of the square of the fx is equal to a x plus 1 of the square, right, over the x plus b x plus 1 plus c. So then x equals to negative 1. This one is gone, this one's gone, right? So now you can see, let's solve the c is equal to the x plus 1 square, right? X plus 1 square times x plus 1 of the square is gone and gone, and this is 3x minus 2. Then let's x equal to negative 1. So we have the negative 1 and the negative 3, negative 5, so it's 5. So now we solve the a and the c, right? Once we solve the a and c, the last step, okay, you have to go back to solve in the regular way. Okay, so now let's see, it's the x and the x plus 1 of the square 3x minus 2, right, should be equal to the negative 2 over x plus b over x plus 1 plus c over plus 5 over x plus 1 of the square. Okay, now you have to do the last step, is x plus 1 of the square is equal to x plus 1 square of the negative 2 plus the b of the x plus 1 times x, then plus the 5 of the x. Okay, now you can see, I mean, we don't have the square, we don't have the square term here, right? So we have the -2 square term and we have a b. So -2 square plus the b square, it should become 0, right? So final b is 2. Okay, so by using this way, you can see it's a little bit faster to solve the coefficients. Okay, next, so we want to seek of this problem. Okay, so now we need to do what is the, we need to see what is the f of the fx first. Okay, so we know fx is this, so f of the fx, right, is equal to the 2 of the fx minus 1. Okay, so now we divide the case into two different cases, right? We have the case 1, right? We want to do is the if fx is less than 1/2, right? So now we know the f of the fx, okay, is becomes the 1 minus 2 fx. Okay, and the 1 minus 2 fx, and we know the 2 fx is this, right? Is 1 minus 2 1 minus 2 fx equals x, right? 2 fx equals x. Then we can see the fx is equal to the 1 minus x, 1 minus x over 2. Okay, so the fx is equal to 1 minus x over 2, right? And also fx equal to, and also fx equals to 2x minus 1, right? Let's draw the 2x minus 1, okay? The 2x minus 1, the equal, the 0 case is half, right? Is 1/2 of 0. Okay, so the slope is k equals 2, right? So that means when it is, when it is 1, right? You are at 1. When it is 0, you are also at 1. Okay, so this is fx equal to 2x minus 1 absolute value, right? Now this one, right? When it is the 1, we are at when it is 1, we are at 0, right? And when it, when it is 1, we are at 0. When it is 0, we are at half. It's something like this, right? But there is a definition. We need to be fx, right? Should be less or equal than less than 1/2. That means the only valid section is here, because this is rule 1/2. Okay, so the only section and the intersection of this one and this one, you can see we have 2 intersects. Okay, if you now you can try to solve the x here, right? Okay, so the first solution is the 2 over 1 minus x is equal to the 1 minus 2x. The second solution is 1 minus x over 2 is equal to the 2x minus 1. Okay, so this solution gives us the x equal to the 1/3, and this one gives us x equal to the 3 over 5. Okay, so this is the case 1, right? Now the next we have the case 2. Okay, the case 2 is the fx is greater or equal than equal than 1/2, right? Then the f of the fx is equal to the 2fx minus 1 is equal to x. Then you can see the fx is equal to x plus 1 over 2. Okay, now we need to draw x plus 1 over 2. Okay, so we still have the same thing. Here is the 1/2 and 0, and we have its 1 here, and we have a 1 here at 1, right? It's 1 of the 0. So here is the here is the 2x minus 1. Okay, now then we need to see the other function is the 2x plus 1, right? So x equal 1, it is x equal 1, it is 1, right? It's here. Then x equals 0, it's half. So it's something like this, right? And also we require the fx greater or equal than 1/2. So it's something like this, right? So we have two intersections, one here, right? Okay, so you can see here that we have a solution is x equals 1, right? And we have another solution is the it's 1 minus 2x equals half of the x plus 1. That means the 2 minus the 4x is equal to x plus 1. So we can see the x equal to 1 over 5. Okay, so that's the 4 solutions to this problem. So for this one, it's by drawing it's much simpler. Okay, so we have the two solutions. It's 3 and 7, right? So you can see if we have the distance of this one and distance of this one, right? So here is 10. So now it's this distance is delta. So you can see it's the 10 plus delta is 10 plus 2 delta here, right? If a point is here, okay? This is the case 1. For case 2 is here. It's p, right? It's 10 plus 2p. Case 1, case 2. For case 3 is somewhere in the middle. You can see it's always 10. So the smallest one is 10. Okay, so for this one, we are going to write the function in the. Okay, so first we need to find the slope, and then we can find the 0 points. Okay, here the 0 points is 1, 2, 3, 4, right? So the -4 and 0, you must pass in this point, right? And the slope is 1 to 1. So the slope is k equal -1, and this one is k equals 1, right? So now we can write this one is this section will be the x plus 4, because when the 4 is when the x is -4, it is 0, right? And it's a negative value, right? So here, so this is the solution of the A. Okay, so to the B, it's also passing through the 1, 2, 3. Okay, -3, and it's 1, 2, 3, 1, 2, 3, 4. Okay, so it passes through the -3 and 4. Okay, so that means, I mean, when it is the -3, right, means we must have this by symmetry, and the k is also +1 -1, right? So it's this, and we know when x equal to -3, it is 4, so +4, then y equal this. Okay. Now the C the C will have this, right? So we have the from the 1, 2. So when x is greater than -2 and less or equal than 1, then the answer is 1, 2, 3. Okay, so the y equals 3. Then on the other side, it's a k equals -2 and k equals 2, right? So when k equals -2 and 2, so you can see in this one, if you remember this, did you see that between 3 and 7 they are constant? Okay, now once you see the constant, it must mean it is x plus 2 and x minus 3, x minus 1, right? And you add them together, then it will causing a constant, right? And you can see it's, if I put alpha and the beta, we can adjust it. We can adjust the value, right? So now you can see, because here is -2, right? So before here we have -x minus -2 and -x plus 1. So that's why we have -2 of the 2x. Okay. Now this is how you get the -2x, and you get the plus 2x. Okay. Okay. Now let's see. So if it is the case, right? So between this, it will be the positive, this one, plus 1 minus x is 3. See, it's 3. So that means the c will be equal 0. We don't need any adjustment. Y equal this. The last one is d, right? The d, you can see the x is, when x is less or equal than -1, 1, 2, 3, or less, greater or equal than -1, less or equal than 3, then you can see the value is 2. Y equals 2. Okay, so the k is on the left is -2, on the right side is 2. Now you can see what you can see is that we can also write as the x plus 1, then plus the x minus 3, then plus c. Okay, so now let's see between this, right? Between this, we have the x plus 1 is positive and the plus 3 minus x. So we have the 4. In order to get is 2, we need to take out 2. Okay. So here, this is the, so these are all the solutions. Okay. Next. So what we know, this is the case, what's the maximum value of the 4x? Okay, so let's draw a picture first. Okay, so you can see the x has been divided into the 4. Okay, 1, 4. So the x should be either less than 40 and greater than 40, right? So the y is 3. So we're cutting the whole plane into the 1, 2, 3, 4 sections, right? Let's do the section by section. Okay, let's do the first section. Okay, let's see if this is here. So we have the x minus 4 plus the y minus 3 is equal to 4, less or equal than 4. So x plus y less or equal than, this is the 7 is 11. Okay, so it's less or equal than 11. So when the x equals 4, y equals 7. 1, 2, 3, 4. Okay, so this is the 4, 7. Okay, now let's see when y equals 3, right? Y equals 3, x equals 8. So it's 8, 3. So this is the line of the first section. And for the second section, you can see the k is either 2 plus 1 or minus 1. So it's something like, so it's 4 here, right? And so it's the also 4. Did you see the 7 over 3, the distance is 4, so the distance is 4 here. We need, if by symmetry, we need to be 4 here. So 3 is negative 1. So it should be like this. Okay, it's a square. So now the distance here is also the 4, right? Now we need the 4, so this is the 4, and this is the 4. Okay, so you can see for the first one we need to be less than 11, so that's this area, so they constructed a square. ABCD is a square. Okay, once we constructed this, then we see let's see the C equals the 4x plus 5y, right? So you can see the slope. Okay, so the 5y is equal to the negative 4x plus c, then divided by 5, right? So now you can see the slope is negative 4, it's a little bit less than the negative 1, right? So it's a little bit more flat. So it will be something like this. This is the slope. So we have a section of this parallel line cutting through this, right? So the furthest, the biggest value should be somewhere not cutting through here, because when they're cutting through here, this is the intersection. You can move up until you can just touch one point of this section. Okay, so you can see clearly here the answer is you have to passing through the 4, 7, right? Okay, now let's make sure it's passing through the 4, 7. Okay, so C is equal to the 4x plus 5y, and it's passing through the 4 and 7. So C is equal to 4 times 4 plus 5 times 7. So it's 16 plus 35 is 151. So this is the maximum value. Next. Okay, so we need to talk about the casework, right? So first, the casework is the case 1 is the x is greater or equal than the log of the y, right? So that means the y need to be less or equal than the e exponential to the x, right? Then we have the x minus the log of y is equal to the x plus the log of y. Now we could have the log of y is equal to 0, means y equals 1, right? So that means okay, that means when y equals 1, right? So the y equals 1, right? So x need to be greater equal than the log of the 1 is equal to the 0. So when y equals 1, okay, x greater or equal than 0, that's the solution. Okay, then the case 2 is x is less than log y, right? In this case, we have the log of y minus x is equal to the x plus the log of y. So we can solve the solution x equals 0. So when x equals to 0, right? When x equals to 0, we require the log of y is greater than 0, means y should greater than 1. Okay, so the second solution is x equals to 0, y greater than 1. Okay, then next. So we want to graph this one and this one. Okay, so now let's graph it. Okay, so you can see the graph is of absolute value x minus a, right? It must be somewhere related with the a. So here is the x equals a, right? So the center is when x is a, we have the a and the b, right? We have the a and b. So you can see when x greater than the a, right? So it is the y is equal to negative x plus a, then plus b. So you can see the this is the greater than 1 is the negative. Okay, so it's a negative negative 1. So k equals the negative 1 in this range, right? Okay, then when a is less than when the x is less than a, so it is 1. So this is the 90 degrees, right? So k equals 1. Then this k equals negative 1. So they construct the 90 degrees. The second thing is also very similar. So let's draw is a c and d. Let's see, this is the x equals c, right? So we have when x equals c and it is d, okay? So it is c and d. Okay, but its opposite is when x is greater than equal than c, then y is x minus c plus d. So you can see it's a positive. It's a positive 1, right? So here means it is positive 1, k equal 1. So they also negative 1. They also construct this, and also here is another one, right? So now we constructed the a, b, and the c, d here, and also we constructed these 2 points, right? Okay, now we know the intersect of the point are 2, 5 and 8, 3. Okay, let's see, this is the 2, 5 and this is the 8, 3, because my picture is not that good. Okay, but let's do it. Okay, so we know this point A and this point B. We want to know the A plus C, right? Okay, you can think about it. Okay, this is sorry. This is the rectangle. This is the rectangle, right? Okay, so the A is the x coordinates of this, C is the x coordinates of this. That means the half of the A and C is the center point P, right? So the xp is the half of the A plus C, right? And half of the B plus D. And the P is also the center point of AB, right? So P is also the half of the 2 plus 8 and the half of the 5 plus 3. Okay, now you can see the A plus C equals 10, the B plus D equals 8. Okay, fully utilize your geometry. Okay, if you use the geometry, it's much faster. But if you want to calculate it, it takes time. Next. So we know the x, y are non-zero such that this one. So what is the let's draw a picture first. Okay, x plus y equals 3. Okay, so we cutting the x into 2 different regions, right? The 2 different region is x less than equal than 0 or greater than equal than 0. So in this case, it's x plus y equals 3, right? So if x greater than 0 is like it's 3. It will be this, okay? And if x is less than 1, that it will be the 90 degrees, right? So it will be this. Okay, so this is the 3 and 0 is the negative 3 and 0. Okay, now let's draw the second one. Okay, second one, if you can see, is x root y plus x cubed is equal to 0. If x equal to 0, then you can do any y, right? If x equals 0, this one must be 0 with any y. Okay, so that's this. Okay, and if x is not 0, now if x is less than 0 is negative x y plus x cubed is equal to 0. Now you can not 0, you can cancel it. So y equal x squared. Okay, otherwise if positive, you can add y equal plus x cubed equal to 0. You can cancel it. Then you can see it's y equal negative x squared. Okay, So after we draw this, okay, now we can see how to do it. Okay, so we only have one intersection here, right? And this one is y is equal to the x plus 3, right? For this line. Okay, so now you can see the x minus y is equal to -3. This is the solution. Okay, last one. So we want to see how many numbers can calculate this. Okay, we need to draw a picture of the left side and the right side first. Okay, so the left side is more complicated. Let's see is y equals the x squared minus 1, then minus 1, the x squared. Okay, let's see inside. Okay, the first is we take out the layer by layer, right? So there is a case is x squared minus 1 is greater equal than 1, and x squared minus 1 is less than 1, right? Greater than 1 or less or equal than 1. Okay, that's cutting like this. It doesn't matter. So if x squared is x squared should be greater or equal than 0, right? So if you need to be greater or equal than 1, this one means the x squared need to be greater or equal. Equivalently is the x squared is need to be greater or equal than 2. Okay, here this one means the x squared is less or equal than 0 and 1. Okay, now let's see. Okay, x squared is yes 0 and 1. So now let's see the first section is this, right? So if this is the case, x squared minus 1 greater than 1, that means this part is greater than 1. So we can see it's the y equals the x squared minus the 2. Okay, because this part greater than 1, right? So you can just directly take it away. Now let's see is the, so now we have the we need the x squared greater equal than 2, right? So we have the case of the negative root 2 of the 0 and the positive root 2 of the 0, right? So it's 0. Now we can see it's 0 and 2, right? Here is the we cannot take this, but we can extend this to see how it looks like. Okay, so this is the first section. Okay, so the second section is x squared is less than, okay, it's 2. As x squared need to be less than, minus 1 is less or equal than 1, right? So it can be take 2 and 0. So that's it, x squared greater than 0. So now this one will be the 1 minus, right? And the x squared then minus 1. Okay, so in this case, we need to further divide this case into two cases. Okay, let me erase this. Okay, yeah, I cannot write the okay, we can further divide this one because we need to see this one, we need to take off this, right? So we have the x is greater or equal than -1 or to -1, or x is greater than 1 and less than root 2, right? So there are two cases. So for the first case, this is negative number, right? So it's 1 minus the 1 minus x squared. So it equals to the x squared. Okay, so for the first one, we have the x squared because it's between the 1 and the -1. So x squared is 1, 1, right? So it's 1 and 1. So these 2 points are the 1, 1 and the -1 and 1. Okay, that if this is the case, right, we know this is the positive number, right? So it becomes the 1 minus x squared minus 1, okay? Then it will become the 2 minus x squared. So the maximum is 2, right? So it's this one, 0, 2, and this one. Okay, so now we figure out on the left side, we figure out the function plot on the left side. This is the most difficult part. Okay, now let's do the other one. So you can see the other 2x is simple, right? It's passing this point, 0, 1, and it's increasing very fast, right? So now let's see how many points. 1, 2, 3. Okay, so that's why you have 3 of solutions. Okay, so that's it for the challenge problem of this chapter. Thank you. Bye bye.